All right, folks, it's Bass Action back in action. On this video, what I'm going to do is I'm going to go through some basic triangles and solving triangles and what that means. And we're going to talk about the best techniques to use on this so that you get the most accurate answers possible. So for starters, let's take a look up here at the very top, this important disclaimer. I can't emphasize this enough. Trigonometry will not give you an exact answer. So before you ever try using trigonometry, you should always try to use an exact method first. If an exact method is available to you, you need to use that before you use trigonometry. And if I tell you, leave your answer in exact terms, I'm telling you in coded language that one of these methods must be available. Special right triangles, those are the 30-60-90s and the 45-45-90s, simple Pythagorean theorem, or geometric mean. Okay, once you have eliminated that those are not available for you, then we're going to jump into our Sohcahtoa. So just a reminder on our Sohcahtoa here, the S stands for sine, the C is for cosine, the T is for tangent. Remember that when we write the ratios, what comes first has to go on top. So sine is going to be opposite over hypotenuse, cosine is going to be adjacent over hypotenuse, and tangent is going to be the opposite over the adjacent. So let's take a look at an example. The directions will tell you to solve the triangle, and what that means is to find all the missing values. So some of those values we'll need to use trigonometry, and some of those values we will not. So for example, part A here, it asks us to find x. X is going to be easy to find here. No trigonometry is going to be required because we can see that we know the measure of this angle and the two acute angles need to be complementary. So all we need to do is our 90 minus our 50 and we would get 40 degrees. Okay, so that would be pretty easy. Never hurts to go ahead and put it in the picture. Now, when I go to find y, I know that I'm not going to be able to use any of my methods because it's not a special triangle and no Pythagorean theorems available. So what we first need to do is we need to choose a point of perspective for the triangle. Although it technically doesn't matter what you choose, it's always best to choose the angle that you were given, not the angle that you calculated, just in case you made a mistake. So on this problem, what I can see is that I know the measure of this leg, that's 5, and I'm going to start by finding y, so I'm looking for y here. So from my angle of 50 degrees, y is my opposite leg, so y is going to be the opposite leg, so I'm going to label that as an O, and the 5 is the adjacent leg. Remember, we typically just call them opposites and adjacents. And then when we look at our Sohcahtoa up above, the ratio that uses the O and the A is the tangent. So when I go ahead and I want to do this, what I'm going to say is the tangent of 50 is equal to the opposite, which is y, over the adjacent, which is 5. Now, I always like to just imagine this left side is over 1 because it's a little bit easier to see when we cross multiply. So then we get y equals 5 times the tangent of 50. And I want you to try to type this in your calculator, keeping in mind that if your calculator's not in the right mode, you might not be able to get this answer. Depending on our types of calculators, you might not be able to get this answer, but give it your best shot. And if you don't, I'll show you how to get the numbers in your calculator when you come into class. We're going to round our side measures to tenths on this problem. And so when I type this in my calculator and I round to tenths, I get 6.0. Now, when I go to find z, what's important is that I do not want to do the Pythagorean theorem because this value here is an approximation. So if I try to square this number for the Pythagorean theorem, it's going to magnify the amount that I rounded. So instead of using Pythagorean theorem, I need to do trigonometry again. Now, when I want to find z, I still know the measure of the adjacent, but now I want the measure of the hypotenuse. So I know the adjacent, I want the hypotenuse. Looking up above, that's cosine. So cosine of 50, remember the adjacent needs to go on top, so now the 5 goes in the numerator and the z goes in the denominator. When I cross multiply this, now I'm going to have z times the cosine of 50 equals my 5. So z is actually going to be 5 divided by the cosine of 50. So again, try to type this in your calculator, and if you can't get these values, don't stress about it. I'll show you how to do it in class. Again, we're going to round to tenths, and you should get 7.8 for this one. Okay, moving on to our next triangle. On this triangle, we're going to go the other direction. We're going to find angle measures. So instead of finding sides, we're going to use our trigonometry to find angles. So for starters, we're going to solve for x, and what we can see on solving for x on this problem is that we actually know 2 legs in the triangle. So again, we do not need to do any trigonometry on this. We could do one of our exact techniques, and we could do the Pythagorean theorem. So we'll have our x squared, our 2 square root of 22 squared, plus our 9 squared. So when my 2 square root of 22 squared is really a 4 times 22, or 88, plus my 81. So my x is going to be the square root of 169. That, of course, is a nice 13. Okay. So we've got that nice 13, and we're all done on that. Now, when we want to go find our angle, we just choose an angle that we want to find. So let's just find these alphabetically. So we're going to find y first, so that becomes our point of perspective. We look at what we know, and always try to go with what's been given, not with what you calculated. So I know this 2 radical 22, and I know this 9. So I know the opposite. Keep doing that with the highlighter there. Sorry, guys. I know the opposite, and I know the adjacent. So what I can say in my calculator is that my angle y is going to be the inverse tangent. That's going to tell the calculator that we're going to give it the ratio. That our angle y, we know the ratio is 2 radical 22 divided by 9. Now this one can be especially tricky to type in your calculator, but give it a shot. When you type that ratio with the inverse notation into your calculator, it should tell you the angle that generated. And our angle, we're going to round to the whole number, is going to be 46 degrees. Okay. Now, to find z, the easiest way to find z, since we don't have to magnify it by putting in a Pythagorean theorem, the easiest way to find it is just subtract it from 90. Use those nice complementary angles. That'll save you some time, and you'll get 44 degrees. If you wanted to type this into your calculator with your inverse tangent notation, you could do inverse tangent, change your perspective, and then it would be 9 divided by 2 radical 22. So either way, you'll get that answer, but I would just subtract from 90. Okay, our last bit that we're going to do here is we're going to find some indicated ratios, and these questions are often the hardest for students. When it says to find the indicated ratio, all that this is asking you to do is write a fraction. Okay, so it's just asking you to write a fraction. So for example, when it's asking you to find, let's say, sine, cosine, or tangent, it's wanting you to do, for example, on the sine, it's wanting you to write the opposite over the hypotenuse. The cosine, it wants you to do the adjacent over the hypotenuse. And the tangent, it wants you to do the opposite over the adjacent. Of course, that means we need to reduce our fractions, we need to simplify our fractions, we need to rationalize our fractions, we need to do all of those things. So we'll get to those in just a moment. Let's come look at our triangle over here. I know this leg is 4. I know the hypotenuse is 2 radical 7, but I don't know the measure of this side. I need to find this side before I can answer any of these questions over here. And since I have an exact technique available to me, I'm going to use that exact technique. So I'm going to call this my x, and I'm going to do my Pythagorean theorem. So I have my 2 square root of 7 squared, and then I'm going to have my 4 squared plus my x squared. So I'm going to have a 28 equals my 16 plus my x squared. So my x is going to be the square root of 12. In other words, my x, simplifying that radical, is 2 radical 3. So that is my last side there. Now let's come over here and take a look at the ratios I want to find. So on example 3A, I want to find the sine of angle E, which means I need to choose angle E as my point of perspective. So from E, I want to know the opposite, that's my 4, over my hypotenuse of 2 radical 7. So I'm going to do 4 over 2 radical 7. I'm going to reduce that fraction and make it a 2 over a radical 7, and then I always need to rationalize 2 radical 7 over 7. So when it asks for the ratio, it wants that fraction, that ratio. It does not want you to give the angle. For the cosine of E, I'm going to stand in that same perspective again, but now I'm going to do the adjacent over the hypotenuse. So my adjacent is my 2 radical 3 that I found with my Pythagorean theorem. My hypotenuse is 2 radical 7. Of course, those 2's cancel, and then I can rationalize by multiplying the top and the bottom by radical 7. So my final answer is a square root of 21 over 7. Lastly, I'm going to find the tangent of W. Okay, so notice that our perspective is going to change on this problem. So now I'm going to come stand up here at W, and if my opposite is now here and my adjacent is now here, they change places. So tangent of W, my opposite is 2 radical 3, my adjacent is 4, and I can just reduce that fraction and I get a radical 3 over 2. So you always have to make sure that you've got your point of perspective correct. Again, if you struggled on the calculator stuff from above, don't worry, I'll show you how to get that in your calculator, but if you were able to figure it out, you're a step ahead. Great. And I'll do more examples in class.